and welcome to C3 Streamland. So in continuation with the lesson plan transformations and symmetry, this is the second video in which we are going to talk about rigid transformations. So basically rigid transformations are the one that basically they won't change the shape of the polygon or object or image when you move that image from one place to another or in one way or the other, right? So there are basically three types of rigid transformations. One is translation, and this is how this looks like. This means picking up that shape and just putting it somewhere else. Yes, that is the translation, which merely specifies the movement of that particular image or shape or object. Another is reflection. Second transformation is reflection. So basically reflection is flipping the object along any common axis. So as you can see here, this line, slanted line, acts as a mirror. So and the polygon B dash acts like a reflection of polygon B, right? And third type of transformation is rotation. That means you take a point and you rotate the shape with that point being in a center, and that's how rotation transformation look like. So translations are very simple. Basically, if we plot it on a graph, we should be able to plot coordinates for it. For example, if this is A and it has been moved here, so we can say that A has been translated. I can simply count 1, 2, 3, 4, 5. So 5 units to the right and 1 unit up, and that's the translation. That is the transformation that has happened for this particular trapezoid, right? What about the circle? Circle has been moved, let's say 1, 2, 3, 4 units to the left. So for left I will use negative integers, so -4, and I can say maybe 1, 2, 3 units up, right? Or maybe not. Okay, 2 units, 2 units up, right? And that's how the translation works, right? We can definitely use mathigon to translate these points. Whenever there are negative integers, you can translate the object left. So 1, 2, 3, 4, and -2 means 2 down. So and whenever we have to go right, we can use a positive integer, 1, 2, 3, 4, 5, and then 1 unit down, right? So that's how translation works. For reflection, you need to have an axis, right? So basically, if I draw a line here, I can say that along this line, these two objects are reflected. For this particular image, I can draw a diagonal line which uh, divides this image into exactly two parts. So that is my reflection transformation. And using mathigon, you can draw different shapes you can reflect. So you can try this exercise at home, right? Now some mathematical terms here. This particular point is called a line of reflection. So when I move this particular point, as you can see, the reflection is either merging into the actual image or going farther based on the line of image. So basically these two images and all the vertex of this will be at exactly same distance from this particular line of reflection, right? uh, Next is rotation transformation. So for rotation transformation, you will have a point, and along with you can actually rotate. So this point here is center of rotation, and there might be instructions saying rotate 90-degree clockwise. So I can simply draw this particular point over here. I'm going to try and see if I can rotate this square 90-degree clockwise. And if it says anti-clockwise or clockwise, basically clockwise rotation is considered as negative, and anti-clockwise rotation is considered as positive. And just like in reflection, you have line of reflection. For rotation, you have center of rotation, uh, because when the center will move, your rotation or the shape, the position of the shape which will be the final position will be changed according to the rotation. So in next video we will talk about different types of symmetries. Happy exploring.